Okay. Short sound check.
Yes.
Fabio, kannst du uns hören? Kannst du mal bitte in den Chat reinschreiben, ob alles funktioniert?
Wunderbar, ich höre euch sehr, sehr gut.
Brauchen wir eine Kamera oder können wir die Kamera ausmachen?
Ihr könnt die Kamera auslassen, dann läuft es vielleicht runter.
Okay, gut.
Okay.
Okay, everything's fine. Ja. Genau.
Okay, thank you. Well, Jennifer asked me to give you an introduction to statistics. Have any of you studied anything about statistics before? Okay, so I'm starting at the beginning. And I want to introduce the logic behind the statistics. And so I'll show you a few of the formulas to help you understand the logic, but I'm not going to go through the calculations. We can have computers do the calculations for us, which is much faster. But you need to understand the logic of what the statistics is trying to do so you can interpret the results so that they're meaningful to you. And there are two kinds of statistics, or there are really two uses of statistics. One is descriptive. You want to describe a population. How can we characterize some population data? And the other is inferential. We want to make some inferences. And typically we have some sample that we've collected some way. Maybe it's a convenient sample, maybe it's a representative sample, because we want to make generalizations about a larger population. So we call that inferential statistics. And so the most common descriptive statistics, the mathematicians call it the mean, but we call it the average. And how do you get the average? Well, add up the scores, divide by the number of scores. It's that simple, right? So you've all been doing that for a long time. And the median is the middle score. If you line up all of the scores from the highest to the lowest, which one's right in the middle? And that's useful because sometimes the mean is not very useful. Like if you wanted to compare two groups on income. Well, if you took an average, maybe this group has one billionaire and that group doesn't. And that billionaire makes it look like, oh, the average is everybody's millions of dollars. Very misleading. But if you say, what's the middle score? The middle score, that's more accurate. Because the mean is subject to all these extreme scores. And when you're comparing means, we need to pay attention. Are there some extreme scores in there that are making it very misleading? But again, so that when we report things like income, we always use the median. And there are many other times where giving the mean would be misleading. And so the median is very useful for those kinds of things. Or like age, you're talking about age. Well, we can talk about the range. I didn't put that down. The range is the lowest score to the highest. I have some questionnaire data I analyzed. It runs from 18 to 84. But again, median age gives a better feel for the just averaging, because having one extreme score again can be misleading. So again, we will talk about median age, median income, any case where you can have a few extreme scores that make it misleading. And then mode, that's just the most common score. If you were to plot them, plot a frequency distribution of the height is how many of each score, wherever the hump is, the peak, we call that the mode. And sometimes things are bimodal. So you may have a class of students and there are a lot of strong students, and a lot of weak students. And so instead of having a distribution that looks like this, you get like a two-hump camel. So you got half the classes here and half the classes there. So we call that a bimodal distribution because there are two of them. And then the standard deviation, what we're trying to get at here is how spread out is it? Is it very narrow or is it huge? Like on income, you know, most people have about the same income, or is it really spread out? And so the standard deviation is a measure of that. And what you do, you want to know is how much do things vary from the mean? So the formula for each score, you subtract it from the mean, and we square it to get rid of the pluses and minuses. And then add them up and divide by the number of cases, and then take the square root to get it back to the same units you start with before you squared it. So this is the standard deviation. So oftentimes you'll see reports that this is the mean and this is the standard deviation. And then sometimes we want to know, well, compare two groups, well, is this standard deviation bigger than that one? Meaning there's a lot more spread in this group than there is in this group. And that becomes important. Now, when something has a random component, like IQ scores or height or lots of things, it typically follows what we call a normal distribution. It's actually a Gaussian distribution, but we don't need to worry about that. Let the mathematicians worry about how to calculate it. But you have this distribution, and in the case of IQ, if you calculate the standard deviation, it's usually 15. So if you look on this chart, this goes from IQ of 100 up to 115, 130, 145. So we call it 1, 2, 3 standard deviations. And then below the mean, we go down 1, 2, 3, goes down to 85, 70, and 55. And it turns out that a normal distribution has this, you can calculate the area under the curve. And that's pretty much the same. So anything with a random component tends to have a similar distribution. And it turns out that, about 68% are between +1 and -1. And so 68% of the people have an IQ between 85 and 115. And then you go up another standard deviation, and then we pick up more people. And of course, the farther you go, the fewer people there are, so it doesn't add as much. So it's useful to know this. So we often calculate the distribution, and if it is a normal distribution, which it usually is, if it's something random. And so as long as you know the mean, you know the standard deviation, you can pretty much estimate how many people are going to have each of the scores. So that's useful. That's useful. Now, there are a number of basic inferential statistics. Beginning stat class will always teach these things, or at least it ought to. T-test is to compare the means of two samples. On the average, do women rate this higher than men? Whatever it is. The F-test is similar, but we have more than two samples. Say, we want to look at different ethnic groups' attitude on something. Maybe political attitudes. And so we have several different groups, and we want to compare the means of each of these groups. So we call that an F-test. And the T-test and F-test are for comparing means. Whereas a chi-square is for comparing counts or percentages. So you want to know what is the distribution of scores in this group and the distribution of scores in this group. Are they the same or are they different? Or maybe choice of musical instruments. Is there a difference between men and women? So you look at the percentage of women who have each of several instruments, and percentage of men who have each of several instruments, and then you want to compare, are they the same or are they different? And a chi-square test will allow you to do that. And then correlation, you want to compare two factors to see if they go together or not. For example, are taller people heavier? Well, they tend to. Is it always true? No. If you lined up all the people by height and all the people by weight, if they're in the same order, that would be a perfect correlation. That would be 1. If there's no relationship whatsoever at all, that would be 0. But if there's some relationship, there's going to be somewhere between 0 and 1. And that's what that would allow you to do. So we'll talk a little bit more about the logic of each one of these tests in this and others. So the t-test, the question is, we're always trying to make an inference about a population, not just this sample, right? We have a sample, say we want to compare the men and the women, and it's not just a sample that we care about. We want to be able to generalize about some larger group. What does this sample represent? All musicians, all people in the world, all people in your country. So we think about, where does this sample come from? Where did we recruit it from? Was it recruited in some random way so we can really generalize about the whole population? On voter surveys, they try to randomly select people to try to represent the whole population, whereas you just take a few people off the street. Well, it may apply people to walking down that street, but how do you know if it applies to anybody else? So that's always a concern. What's the population you're trying to represent? And okay, so in this example, you have, are men and women equally likely to say that they like a particular genre of music? And so you have to rate this. I like it on a scale from 1 to 9, 0 to 8, 1 to 100, whatever it is. And then if we plot the distribution of scores for the men, plot the distribution of scores for the women, you can find that they really overlap. They really overlap. And that implies that, they could have come from the same population or from populations that are identical, right? That we want to say that, for men in general, women in general, or women studying music and men studying music, the distribution is, it could be the same if they overlap a lot, right? On the other hand, if the distributions are far apart, then it's less likely that they came from the same distribution or identical distributions, isn't it? That's harder. And what the statistical test is trying to say is, well, if these really came from the same population or identical populations, how likely is it we could have gotten this big a difference by chance? When you randomly select something, say you flip a coin, you flip a coin 10 times, if it's honest, you expect it to come up heads about half the time. Is it always going to be half? No. Could be 9 times, but that's very rare. It's more likely 4, 5, or 6, right? When you keep flipping it and flipping it. The more you flip it, the more likely it's going to average out to 5, right? So sample size matters, right? In a small sample, it's very easy to get differences by chance. In a huge sample, oh, much harder, much harder. And that's why it's better to have a sample size of 100 rather than 30. Well, I've got a questionnaire, the cross-cultural study of intimate relationships. I've got 9,000. So teeny tiny differences are very unlikely to do to chance. Whether they're meaningful or not, that's another question. So this is the logic. How big a difference could you get purely by chance? And so what this T statistic does, this horrible formula, it's measuring the overlap. That's what the formula means, the overlap. So we take the difference at the means. In other words, how close together are the means? Are they far apart? Are they close together? But then how spread out is it? You know, if you have a widespread and they're this far apart with a real widespread, well, maybe they could have come from the same one. But if they're real narrow and they're this far apart, it's less likely they came from the same. So it's not just how far apart the means are, but how wide the spread is, because both of those determine the overlap, right? And that's what the T measures, the overlap. So you got the measure of the overlap, and then down below, you have the standard deviation. That's what that S is, which is the measure of spread, and you have to average it somewhat. And that's what that funny formula is. It's averaging these two samples if they're two different sizes. So we're not going to worry about actually calculating it, but I want you to get the logic, the idea. It's a measure of the overlap. And then depending on the sample size, we look at some mathematicians have calculated the probability distribution for us. And they have plotted how big a difference. Let me see that. Well, here, I'll show that in a minute. The null hypothesis says, oh, they came from the same population. And what we want to know is this big a difference so unlikely to have occurred by chance that we can reject the null? That's the logic of the test. Can we reject the null hypothesis, which says there's no difference? Okay. And so we want to know is how likely is it that big a t-value could occur by chance if we did it many, many times? And so some mathematicians have calculated this for us. So if you plot, what's the probability of getting different t-values? In other words, what that shows is a tiny difference occurs very often by chance, right? Very easily. But a large difference, that's much less likely to occur by chance. And on one end, we call it two-tailed distribution. On this end, one group is higher, and this end, the other group is higher. So when we subtract the two means, either plus or minus, depending on which mean is higher than the other one. And the rule that we normally use in statistics is, okay, and it's kind of arbitrary, 5%. That's the standard that we use. If the probability that this big a difference could have occurred by chance is less than 5%, you can't way out here in the tail. It just doesn't happen very often. That's what we're looking for. And then we see the difference is statistically significant. Statistically significant. And what that means is unlikely to have been due to chance. Whereas if T is anything closer to the middle, we don't know. It could have occurred by chance. Maybe it did. Maybe it didn't. Maybe it is a real difference. but we don't know. So the goal is to reject the null hypothesis. If we can't reject it, we call it's a null result. Does it mean that there is no difference? No. It means we don't know. We don't know. So maybe what we need to do is do another sample, a bigger sample. And then we can be sure that more certain that this difference wasn't due to chance. So that's the logic of the test. That makes sense? Yeah. Okay, I just said that. Okay, now the F test is the same logic as the T test, right? You have more than two groups. Well, you could do it on two, but that just you give you the same result as the T test. Turns out F test is equal to T squared if you're dealing with just two groups. So we normally just use the F test. If we got more than two groups, you get 3 groups, 4 groups, 5 groups. Oh my God, you can have more groups, but once you start getting more than so many, it's hard to keep in your head. I know from psychology that we can keep 7 plus or minus 2 things in our head at once, juggling things. And so by the time you get to 10 things, forget it. Forget it. And that's why a phone number, that's about the limit of your memory. Short-term memory is a phone number. Or before we had cell phones, I had to remember a dozen phone numbers. Now I have to remember a dozen passwords. And those are typically, about 7 or 8. That I can remember. More than that, yeah. Okay. So, for example, are children, teenagers, and adults equally likely to say they like a particular genre of music? Take samples of children, teenagers, adults, and for a given genre of music, ask them how much they like it. And then we could do an F test to see, are they the same or not? And again, the logic is the same as the T test, right? If the distributions overlap a lot, they could have come from the same population or from identical populations. Meaning, it's just similar. They all have similar tastes. On the other hand, if they're spread out, then it's unlikely. And so what the F test does, just like the T, it says, well, how spread out are they? And so what you do, you look at the variation among the means and compare it to variation in the spread. Because, if these were all, go back here, if each one of those was a real narrow distribution, they might be separate. But when it's spread out, then, so the overlap is determined by 2 things, how far apart the means are and how spread out they are under the means. That makes sense? Okay. And that's what the F test measures. So we calculate the variation among the means, and we calculate the variation among inside them, and take that difference, and that becomes F. And I won't bother to show you the formula, it gets a little bit complicated. But the important point is the logic. The logic is the same. Okay. And again, if the probability of the F value could have occurred by chance, if it's less than 5%, we say again, it's statistically significant. And if we say again, it's a null result. Does it mean they're the same? No. It means we don't know. So we're not proving the null. We're trying to reject the null. That's the logic. Okay. Well, chi-square, again, the logic is similar, but instead of comparing means, we're comparing percentages. Percentages, that's what matters. For example, you want to know, is there a gender difference in preference for classical music or folk music as their favorite genre? Here's some. Suppose you had a sample of 100 men and a sample of 100 women, and 80% of the men said that they preferred classical music over folk music, while 70% of the women said they did. So 80% versus 70%. These are made up values, okay? Is this gender difference bigger than you'd expect by chance? And what this chi-square test says, okay, let's look at the actual values. And in this case, well, 80 of the men say prefer classical, 70% of the women prefer, and then the reverse. And then, but you do, that's the observed value. And then you say, okay, what if the percentages were the same? What if they were the same? And so, oh, well, to get the same percentage, you need 75% of men and women for classical, 25%. That would be the same percentage distribution. Okay? And so here the question is, how much, or the observed value, how much do they differ? How much do they differ from that? And is the amount they differ more than you'd expect by chance? If you just randomly pick people and just happen to get more people that prefer this and just happen to get more people that prefer that. That's always a concern when you're taking samples. You just happen to get more men who prefer it than women who prefer it in your sample. Because we want to generalize to a larger population. So again, we're asking, what's the probability that this big a difference occurred by chance? And so what the what the chi-square does is, oh, okay, well, in each square, we'll take the observed value minus the expected value. We'll square it to get rid of the signs. So it's not pluses and minuses, we get rid of those by squaring it. And then take it as a percentage of the expected. So it's a percentage of the difference. And call it chi-square. And again, some mathematicians have figured out the probability distribution of chi-squared depending on how many cases you have. It varies depending on how many cases you have. But again, it's the same logic. Is the chi-squared you got big enough that it's unlikely to be due to chance? Okay. Okay, and again, if it's big enough, unlikely to be due to chance, less than 5% of the time, statistically significant. And if not, so it's the same logic. Every statistical test has a similar kind of logic. Is the difference bigger than you'd expect by chance? If you just, flipped coins or something. Okay. And again, logical correlation is, okay, we'll compare two different measures. Okay, so this example, comparing the ages of young men and women in couples. If I line them up by age, line them up the men by age, line up the women, is the oldest man with the oldest woman, next oldest, on down the youngest and youngest. Perfect alignment, correlation is 1. Totally random, age doesn't matter whatsoever, correlation is 0. Matters quite a bit, pretty close to 1. Matters not so much, closer to 0. Okay, so that's the logic of the test. And so I graphed some examples of what this looks like. In this case, perfect correlation. You say ages are identical. I'm just showing a few, 6 out of 30 to 100. Now look, in this case, every man is 2 years older than a woman. I've done research on dating couples, and I find on average, the men tend to be about a year older than the women, at least among college students. It's pretty typical. But in that case, the correlation is still 1. Because it's the oldest with the oldest, next oldest, next oldest. So we don't care if the means are different. The correlation ignores that. It ignores that. And it also ignores the spread. What if the men vary more in age than the women? The women are all closer in age than the men are. But again, oldest with the oldest, oldest with the oldest. The correlation is still 1 because we're just looking at the alignment. And we're ignoring the mean, we're ignoring the spread. Whereas here, they don't all align, do they? So the correlation is less than 1. It's greater than 0. There's some alignment. Does that make sense? And that helps us understand the formula. Oh my God. So we take away the mean from the x's, we take away the mean from the y's, from the 2 groups, we divide by the standard deviations. We got rid of the means, we got rid of the standard deviations because they don't matter in the correlation. So what we're basically doing, when we do that, we call each of these a standard score. Standard score is you measure how much does it vary from the mean. Well, you take away the mean and divide by the standard deviation, and that gets rid of the units. So what we're doing is multiplying it, and it turns out if the highest is with the highest, this is going to be, that product is bigger, right? If the highest matched with the highest, when you multiply them, you get a bigger value than if the highest matched with the lowest, you get a lower value. Right? So that's how the R value is measuring the alignment. Okay? And it's a horrible looking formula, but what's the logic? Getting rid of the means, getting rid of the spread, but measuring the alignment by multiplying them together. And then the R value, again, is compared against the probability distribution calculated by mathematicians for us. And then it turns out that the probability distribution varies with the size of the sample. As I said before, with a small sample, it's easy to get variations from the mean, right? Flip the coin 10 times. Pretty easy to get 6, 4, even 7. But if you flip the coin 100 times, on the average, you're going to get closer to 5%. Flip it 1,000 times, very close to 5. So if you flip the coin 1,000 times and you get an average of 7, wow, that's unlikely. So with large samples, even small correlations can be statistically significant. It can be, no, with large samples. Yeah, with very large samples, it's easy to get a statistically significant correlation. With a small sample, it's much harder. I have a cross-cultural study of intimate relationships. I have 9,000 people across from 72 countries around the world. Correlation of R equals 0.03 is statistically significant. Well, you want to know how much of correlation, what does it really mean? How much does it explain? You square it. Now, most of the time in research, we get a correlation of 0.5. We're excited. This is big stuff. And even if we get a correlation of 0.2, we're happy. Correlation of 0.1, we talk about it. But you want to know what it really means, square it. Correlation of 0.5 explains what? 25%. Hoop-de-doo, right? Correlation of 0.3, yay, explains 9. 9%, 0.2, 4%. 0.1, what's explaining? 1%. Oh my God, I've sat through lecture presentations where people have this whole table of correlations of 0.11, 0.12, 0.13, making a big deal out of it. And I'm like, oh my God, you're explaining 1%, 2% at the most? Oh my God. So just because it's statistically significant doesn't necessarily mean it means anything. You know? Yeah. Yeah. Okay, so sample size matters. Well, now we're going to talk about some advanced statistics, because these are things you need to be aware of too. You wouldn't learn about these in the first semester stat course. You learn them in a later course. But you need to know that, again, it's the logic is the same, right? We have something called multiple regression, which instead of correlating two scores, using one to predict the other, we say, well, what if we take into account several scores at once to predict it? And the predictive variables are called the independent variables, and the predicted variables is called the dependent variables. Oh, maybe you want to predict success of college students. I've done these analyses. So my dependent variable is first semester grades. And then I want to look at, what might predict that? Maybe SAT scores, verbal scores, math scores, high school grades, maybe gender, maybe ethnicity. A whole bunch of things could do it, right? So I want to know what combination of these things would allow me to predict who's going to have a GPA of a 2 point, so they're not going to flunk out of school. And then I also did analyses. I want to know, well, which students are going to need some help in English? Because it turns out that your English score in my school is the best predictor of your English grade is the best predictor of your overall grade. Because you need to write in all your courses. And well, some you do math, but all the other ones, right? And it turns out that I looked at all of these things to see what would predict that. And it turns out that two things did, high school grades and SAT verbal scores. Those two things together were the best predictors. And in fact, the other things didn't matter once I took those into account. So any effects of these other variables show up in grades and SAT scores. So I don't need to worry about them. So just those things. So I could use those scores to predict, who needs a beginning writing course before they take the regular writing course. And so that's how we selected which students got that course, based on that kind of analysis. So you can see how this could be useful. So we typically write the prediction as a regression equation. Y is what you're predicting, in this case, first semester GPA. And then each of these factors that we're using as predictors, these were X1, X2, X3. And then the B is what we call the regression coefficient, how much we weight that in doing the calculation. Okay. And the formula is to calculate these things, again, complex. Let the computer do it. And then you want two things out of it. One is you want the regression coefficient, so you know how much each one of them mattered. And it turns out that if the things you're looking at, your independent variables, if they're correlated with each other, which they sometimes are, then sometimes one captures the effects of others. And I found that in my research on intimate relationships. I mean, what predicted satisfaction? What predicted commitment? And it turns out that certain things will capture the effects of other things. So you don't need to have 100 factors. You can narrow it down to a smaller number because they can capture the effects of other factors. And again, R squared is the combined effect of how well do all of these x's together predict the y. And we represent it as an R squared, kind of equivalent to a correlation square. And again, that R squared tells us, oh, what percentage are we explaining? And in my research on intimate relationships, I can explain 76%. That's unheard of in social science research. You know, we're lucky if we get 50%, 25%. Yeah, anything above that is amazing. Correlations are also the basis of something called factor analysis. And the idea is you got a bunch of things and you want to know how do they group together? Juniper and I were looking at some of her, she has some questionnaire data that she gave to musicians. And one of the questions is genre. Which genre? And you do a factor analysis to see, well, which genres go together? In other words, people who like classical music, do they also like pop music? Do they like folk music? What kinds of music do they like? And can we kind of group the genres together? Some people like these things, some people like these things. Sometimes, the idea is if you like one, you like the others. And so you do the factor analysis to see, well, is it all one thing? You like music, it doesn't matter what it is, you like them all. That would be one factor. A two-factor solution would be, well, maybe you got classical folk music here, and you got pop music and dance music over here. And maybe you got one factor, 2, 3, 4, 5. It varies. And in Juniper's data, I think we had 6 factors out of about 20 genres. But that's what it helps us do. And the way that the factor analysis does, it looks at the correlations. For example, okay, here's some data. This is some real data from my questionnaire. I have a multiple identities questionnaire, and I ask people things that they do, and I ask about music that they like. And it turns out that, people who like classical and like the correlation is 0.32. That's not a very high correlation, is it really? Now, normally people get excited about it, but it's really only explaining 9%. But the point is, what this data says is that people who like classical tend to like jazz, and vice versa, right? Yeah, certain amount. On the other hand, people who like classical aren't so big on hip hop. But it's very small, so it's not very. It really doesn't go together. Or top 40. On the other hand, people who like hip hop tend to like top 40. And so what this suggests is, okay, we've got 2 factors here. One factor is classical jazz, and the other is hip hop and top 40. Now, some people, of course, like both. Of course, right? But it's more likely that people who like these 2 are not as likely to like that 2, or it's irrelevant. I mean, zero correlation means, you either do or you don't. Liking classical doesn't predict whether or not you like hip hop or top 40 right? Whereas it does predict that. So that's the logic of factor analysis. How many factors are there and which factors go together? And then if they go together, then maybe we can average them to get a more reliable measure. Oh, this is why you take these attitude tests, these personality tests. They ask you the same darn thing 10 different ways, trying to get out the same thing 10 different ways, right? And the idea is it's going to be more reliable if you ask it 10 ways instead of one. But when you ask it 10 ways, are you really measuring the same thing? Or are you measuring two different things? Like you're doing a study, study conservatives. People are conservative. Well, you can be conservative in different ways, politically, musically, religiously, sexually, you name it, right? Is it all the same? Or is it different things? How many different things? 2, 4, 6, 20? That's what factor analysis will help us figure out, is how many different dimensions do we have? And there it is. Oh, the factor analysis, what it does, it identifies the factors and it has what we call factor loadings, which measures how strongly it goes along with this factor. And this is actual data. Okay. Now, and I want to introduce the logic of another test. It's the same logic as an F test and a T test, but it's looking at combinations of factors. Two very independent variables at the same time. It's called analysis of variance. The variance refers to the spread, the square of the spread. That's the variance. So the standard deviation of the sample we talked about, you square it, we call it the variance. So again, the F test, the F test is analysis of variance. We look at the variation of the means over the variation of the others. And only in this case, it's more complicated. So here's the example. Does liking hip hop differ between college students who go to dance clubs and those who do not? Can we predict liking of hip hop based on going to dance clubs? And does the relationship vary between men and women? Is it the same relationship for men? Does it predict equally well for men and women? Or is it different? So on my questionnaire, I asked how often a month I went to dance clubs. I used to go clubbing every week. I loved it. That's why this is relevant to me, of interest to me. And I found half of them never did. Half of these scholars never went to a dance club. And the other half went at least once a month, some of them many times a month, like me. So here again, we're comparing means. So it's kind of like the chi-square, but we're comparing means instead of percentages. So here we go. So among the men, this is how much they like hip hop. Among men who don't go clubbing, the mean was 5.1 of liking hip hop. And among those who went clubbing, it's 6.0. So for the men, those who go clubbing like it more than those who don't. Among the women, the same is true, but even more so. In other words, the difference is bigger for the women than for the men. Because women who don't go clubbing are less likely to like hip hop. And so we look at the totals across and the totals below. In other words, if we look at men and women in general are about equally likely to like hip hop, right? And among people who go clubbing are more likely to like hip hop than those who don't. And so we call the main effect of clubbing, and by main effect we mean ignoring the other variable. So if we just look at clubbing, forgetting gender, we find, that the main effect of clubbing says, yeah, it does predict hip hop. The main effect of gender, no. There's no gender difference overall. But the interaction effect is looking at, is the effect of clubbing on liking hip hop, is it different for men and women? And that's true in this sample. Clubbing has a bigger effect on women's liking of hip hop than on men's. That's the interaction effect. So two-way ANOVA is very powerful technique for saying, is the effect of something different for two different groups? Is the effect of one variable different? That's important to know. Because a lot of times we know, well, do people like this more than that? Oh, well, which people like it more than that? And oh, does it matter? Does it depend on something else? So that's a powerful technique. And okay, yeah, as I said, interaction effect is what makes ANOVA so useful. It reveals how the effect of one variable may vary as a function of another variable. And there could be three-way higher ANOVAs. I think I once did a four-way ANOVA. Normally only do a two-way or three-way. Beyond that, and the formulas for calculating, but again, the logic is the same. Is the difference bigger than you would expect by chance? That's what all of the statistical tests are like. There are other statistical tests too. All of them have a similar logic. The statistical test is calculated, comparing what you have to what you'd expect by chance. If what you have could occur by chance, rarely, less than 5% of the time, is statistically significant. If it could occur more than that, it's a null result. We don't know what it does. So again, it's the same logic on all of these. Now, as I said, even if it's statistically significant, there may or may not be a practical significance. With very large samples, correlations less than 0.10 can be statistically significant. But as I said, you square it to find out how much it means, and that's 1%. And in my research, I call that a trivial correlation. Anything less than 0.1 is trivial, and I ignore it. I ignore it. It's not worth talking about. Even though other people do. Oh, it's statistically significant. R equals 0.06, yes. I don't. It's not very meaningful. And that makes it easier to boil it down. What really matters? What really matters? And, do you have questions? Went through this faster than I thought. Any questions about statistics? Well, I mentioned my research on intimate relationships. And I thought you might find it interesting to know what some of those results were. So I worked with 30 colleagues around the world, people I had met going to research conferences. In another week and a half, I'm going to go to a research conference in England where I'll meet some of these people. And so I developed a questionnaire and shared it with colleagues to get feedback on it, asking about intimate relationships. And then I asked my colleagues to translate. And then I took their translations and pasted it into copies of my web pages. So it's online in 20 languages. And it turns out that these are in 9 regions around the world. North and South America, East and West Europe, East Asia, Southeast Asia, Oceania, Africa, all over. And I was looking at who has an intimate relationship and what predicts relationship satisfaction and relationship commitment. And I, started out with a questionnaire that's got hundreds of questions and boiled it down to what captures the effects of other factors. And to predict satisfaction and commitment, I put it into 4 categories. One is a suitable partner. A suitable partner. What makes a suitable partner? What's most important? Personality, which includes intelligence, sense of humor, all those kinds of things. Of course that matters, right? Having, desirable features in general. But it turns out that approval of parents and friends. Wow. If your friends and your parents like your partner, that makes it much easier. If they don't like your partner, that's rough. Can you imagine your parents saying, well, you're welcome to go home for the holidays, don't bring your spouse? Can you imagine? I mean, that happens. That happens. That would not be good.
It's stupid, but isn't there more to it than statistics? Like if you say you're more likely to have a fulfilling relationship with your parents' group.
Yeah.
Can we say that you have it because your parents' group, or maybe it is another thing, like your partner is nice, and your parents' group of your partner because he's nice. So the reason why your relationship is good is because it's nice, not because your parents' group.
You're right that those are mixed together, right? If your parents approve of the person, because they're nice. But maybe the person is nice, but your parents disapprove because the person is nice. That can happen, right? So even though the person's nice, and maybe the person's nice enough, you say, forget your parents, you're going to be with this person. That happens, right? But it's still going to be rough. It's going to be hard. But you're right, these things all go together. Okay. The evolutionary psychologists tell us that what men are looking for is young women who are fertile, attractive women who are fertile. And what women are looking for is high status men who can support them and their kids. And I looked at, Bus is one of the people who tried this. I looked at his data. It turns out those things are only moderately important. They're not the most important things. He didn't measure the most important thing. He didn't ask about personality. All he asked about was looks and status. And there is a gender difference, but it's small. I asked 20 things, what's important? What are you looking for in a mate? And it turns out that, personality up there, only moderately important looks, only moderately important status. For both men and women, even though there's a small gender difference, it's not the whole story. Most important, personality, then tied in with approval, parents and friends. So that's one category. Second category is intimacy dimensions. How much you love the person, how emotionally close you feel, how much you disclose, trusting the partner not to lie. That's a big one. Sexual satisfaction, if it's a sexual relationship. Those kinds of things. Third category called exchange processes. Are you getting anything out of the relationship? Any benefits? More benefits than cost? Yeah. Are you equally involved in the relationship? Oh. Because if you're not equally involved in the relationship, the person who is less involved will usually walk away. The person who's more involved wants to keep that person in the relationship. Ah. And if you keep to do that, you get into the other person's wishes, you get into the other person's demand. There's a power imbalance. Less involved person having more power than the more involved person. And that can last for a while, but after a while, either one person gets tired of being dominated, or the other person becomes tired of being pressured to become more committed to the relationship. And the fourth set of factors are conflict resolution. How do you deal with conflict? How do you do it? All relationships have conflict. That's a given. Some have much more than others. That's a threat. Some have much more than others. That's hard. But everybody has conflict. That's normal. Because how do you deal with it? You just calmly discuss things, talk, or do you pout? Do you get angry? Your partner blows up at you. Do you blow up back? Or do you say, wow, you must have had a rough day today? You realize the person is way out of proportion. The reaction is out of proportion. They must be under a lot of stress. And they're sympathetic, saying, you know, can I help you? As opposed to blowing up back. How do you deal with conflict? Now, these four categories I mentioned, suitable partner, intimacy dimensions, exchange processes, conflict resolution, these are not surprising. They're not surprising at all, are they? What's surprising is it's the same across 9 cultural regions. Absolutely the same things across these 9 cultural regions, in spite of any other differences. Arranged marriages. Oh, I've got a sample of arranged marriages. My colleague in Pakistan has arranged marriages and free choice marriages, and so I can compare those two. Well, similar stuff. And it's also true against 8 relationship types. Oh, my sample includes men and women in opposite sex and in same-sex relationships, unmarried and married. Now, some of the levels of things may be different, you know, more commitment in marriage than in not married, but the same things predict commitment and satisfaction. All these things that I mentioned. So what's surprising is it's the same things that matter. Regardless of the kind of relationship, the culture, it's the same things that are important. Yeah. Now, I mentioned these are things that predict satisfaction. 77% of the variation. These are important. They're not trivial things. And then satisfaction, of course, predicts commitment. But I also found that these things predict satisfaction, predicts commitment, but also some of these things predict commitment independent of satisfaction. In other words, if you feel your partner is a really desirable person, or you really love this person, you may hang on to that relationship even if you're not very satisfied. Or you feel very invested in the relationship, spend a lot of money, effort, time building up this relationship, and you think, you know, well, I'll just hang in there, it'll get better. Well, sometimes it gets better. If you go to therapy, maybe it will get better, but a lot of times you just hang in there, it doesn't get better. So some of these things will predict commitment, whether you're satisfied or not. And again, it explains about 77% of commitment. These things together with satisfaction. Yeah. Okay. Well, that's an example of doing statistics for that kind of research. And those,
Like to look whether he has a question.
I've written up those results in a book. It's called Intimate Relationships Across Cultures, a Comparative Study. And it's published in 2019. Oh, the factor of age. Well, age is confounded with the unmarried and the married. The old people are more likely to be married. And it turns out that the result yeah, different terms, different things, with age. The big difference though is I didn't think much about who has a relationship. And it turns out that the four factors I have to bring up on it. Are you ready for it? Stage one, what do you mean stage one? So, education, maybe this will be career, maybe concerned about supporting the family, you want to actually got jobs. So that's where it is up to yeah. No, but again, if you gave me in college, then you deadline, it's not the decision matter in your relationship. It's whether you're ready for that.
Can you say that statistics is all about predicting something? Can you say that?
What we're trying to do is predict something about the population or about the relationship between variables. So in this case, I was interested in can I predict having a relationship? Can I predict satisfaction? Can I predict it? And what factors predict it? And then to whom can I generalize? A lot of the research has been done on U.S. population or Western populations, what we call weird samples, weird Western educated industrial sample. And then there's to find anybody else. And that's one thing great about Einstein. I thought these other populations, Indonesia and Nigeria and all these places. But again, yeah, you're working about can we predict about the population? Can we predict about relationships between various factors?
And follow question. Can you say that if you want to know how to predict the population of the community, you should use statistics and using the other version?
Well, the thing is, if you want to know something about population, in the class of data, the thing is, how do you know what represents the population? Then you find a difference. Was this difference big, small? What if it's significant, then you're more confident that it's not just that you have to be more here. Now, exactly doesn't happen. You only start with these people. And that's why you get this result. It doesn't. But at least it's a tool to use. Yeah, yeah. Okay, how do you get the data? How do I, like, it's from one site or how do you? Okay, you know, people are all over the place on how you do that. I think it's very common. Some people go 1 to 7. Or you know, there's something called a Likert scale. Strongly agree, moderately agree, slightly agree, neutral, slight disagree, moderate disagree, and extreme disagree. So that's very common. 7-point scale goes. That's probably the most common one. Kind of the scale that's used for measuring attitude. Can do is look at these, not just for plus or minus, but I want to know about each individual scale separately. Um, how satisfied are you? How dissatisfied are you? Well, I would rather say I'm satisfied 0 to 8. And then I think what I'm going to say this. See, that's what I'm separately. And so like maybe both. Yeah, watch that and you're not always that's maybe both. You can capture both. Single patient won't capture both. So that's good. And I started using, and a lot of people use it. Probably use 1 to 9, like when you actually rate yourself. How attractive are you? How close are you? How this are you? It's usually 1 to 7. Well, I studied the questionnaire to measure identity. And I know among Americans, people will often say, well, I'm half this, I'm quarter this, I'm 1/8 this. In my case, I'm 3 German, one 5/8 German, one Finnish, and 1/8 something else, I don't even know what it is. So you very often use these fractions, right? Yeah. So it's like, to what extent you can see yourself and we use this integration categories or ethnic categories, and I'll say 0 to 8. So you can say, oh, this is important. And I do that for all the entities. So when I'm asking about religion, sexual identities, you name it. 0 days. So I do that for everything. But it's all over the place. And it probably depends on your population. When you're asking kids, maybe you have a smiling face, a neutral face, and a negative face. And that's it. And I figure I often study college students. Yeah, they can deal with one. And sometimes when people will put a verbal rating test, a little bit moderately, slightly, we want to come up with a bunch of adjectives that each of the numbers. And the problem is, how do you make that equal in space? How much is some? How much is slightly? So I figured in college students, labeling is that not involved in extremely that they figure out to get on without putting the verbal label on. But again, it depends on who you say. Each level of education. What is what are you going to do with it? Sometimes you really get classes, you don't care. Like for something I used to be at the people in your lives. And I was considering, well, how many brothers and sisters do you have? I said you have 0, 1, 2, or 4. Brothers, Important thing is, you have not one or more. And whether they have 3 brothers, 6 brothers, I don't care. I'm in class A in my neighborhood. My mother asked. So always keep in mind, how are you gonna have? And then I was here. Yeah. Two questions. You have to, when you want, it'll help you do the analysis. That's something that's meaningful to you. Any other questions? I do it all online. I used to do it on paper. But then I have a research assistant, type it in the computer. And all online. People online, do they have any questions?
I don't see any questions, but maybe. Hört man uns noch? Ich kann kein Englisch mehr. Can you hear us? Ja doch, okay. Uns sieht man nicht.
Hi. Do you have any questions? Okay. Do you have any questions? Well, research is a lot of work, but it's fun. It's fun when you're thinking of the question. What do you want to know? What are you trying to get at? That's fun. That's very creative time. Yeah, collect the data, that's tedious. Analyzing data, that's tedious. But then once you start to get into the result, yeah. We're running it up. Sharing. That's why. I'm now doing a new study. I'm looking at the impact of COVID on activities, relationships, and well-being. So I asked people, what made you find meaningful? And then how did your involvement in these things change? So I don't know. My interest is twofold. One is looking at, how COVID impact people's lives. But I'm also interested in the early questions. What makes it like relationships? Music matters. Other things matter, nature. I came up with 60 things, so ask me for help. I'm painful people, usually 60 things. And then I'm going to track analysis to see if I can narrow this down to the smaller numbers to talk about. So I don't have to try to talk about 60 and just. So that's my next project. It's analyzing that data. See what I do. Anything else? We've got another minute. All right, well, so let me tell you a little more. I mentioned the intimate relationships questionnaire in the results in this book, Intimate Relationships Across Cultures. I've been doing this multiple identities questionnaire, asking people about all of their different identities. And I'm asking people to what extent they've experienced And how you cope with it. And I was interested in people develop pride to overcome it. And I found that experiencing prejudice tends to make an identity more important to you. And then if identity is important to you, then you're more likely to develop pride in it. And so I found that if you take experience prejudice, that tends to decrease your satisfaction with life, of course. But if the prejudice leads you to consider that identity important, and then you develop pride in that identity, then that boosts your life satisfaction. And oftentimes with identities, I was interested in how people develop their identities. And for example, ethnic identity. Well, oftentimes as a kid, you're in the neighborhood, everyone will like you. Ethnicity doesn't matter. You're all the same. But then when you encounter people who are different, maybe it's in primary school, maybe it's not until high school, maybe it's not until college, then you encounter people who are different, and particularly if they consider you different because of your appearance, your ethnicity, your religion, sexuality, whatever, then that's when that identity becomes important to you. Try to figure out what the heck does it mean to have this identity. How do I cope with it? How do I make acceptance? So, and then oftentimes that involves, so that first step is called, it's called encounter people, particularly if you treat you different. And then you often immerse yourself to find out in that identity. What does it mean to him? You explore your roots. When I was I knew that my father's parents came from a German village in Russia. So I studied Russian, German. I knew it was in Germany back then. I forgot most of it, but I knew it back then. And then I visited Germany to explore my roots. So we often do that. And then hopefully, once you get a better understanding of that, then you try to integrate that ethnic identity with the mainstream that you're in. In my case, the American identity. German American background. One of the few things that I discovered in my travels around Europe was that my identity, my cultural background was just it's English and Italian and Greek and it's pan-European. This is my cultural heritage. Particularly growing up in school, that's what you learn about, European history. And then I visited Japan and China, and I discovered, oh, my cultural heritage is pan-human, right? My cultural heritage is all the cultures I'm aware of. Like I learned about, particularly living in LA. Oh, well, we have American cultures, we have European cultures, we have Asian cultures, you name it, we've got it all. And that's all part of my heritage. And so I consider myself pan-human. And so by encountering others and trying to integrate, what does it mean? How do I fit in? How do I fit in? Not in the whole world. That's my culture. Now my daughter lives in Germany. Now revisiting Germany today. And it turns out that our ancestors were left from about 100 miles from there to go to Russia looking for a new life. And they left Russia to go to America. Then my daughter comes here for job offers. It's a little bit of a full circle. Again, looking for more opportunities. Looking for opportunities or escaping bad things. My grandparents left Russia in a rising nationalism preceded the Russian Revolution. They got out. People who were. Well, so again, hopefully they don't find good about yourself. And it helps to seek out people who are similar to you, but also people who are different. And you share one identity with people that have a different one identity with somebody, but you may have 10 other identities in common. It turns out that you've got about 15 different identities. Probably didn't realize that. You've got health identities, you've got clothing identities, and music identities, and you name it, you got lots of identities. And so you lots of ways that you can relate to somebody, you're similar to them. So you're going to be similar in some ways and different in some ways. And don't let the differences keep you from relating to them. And value the differences. That's one thing I like about all these different cultures. And the mixtures, it's kind of funny. I went to a St. Patrick's Day celebration last year. Well, in St. Patrick's, everybody is hungry and cabbage. Well, in Pasadena, they had corned beef and cabbage tacos. Tacos are Mexican. You can put beef, chicken, or fish, shrimp, whatever. I love shrimp. Anything in a taco, but corned beef. That was different. But again, it shows the fusions that happen to people mixing the cultures and appreciates all of the cultures. And so I wrote a book about that. I think it's called Prejudice. I didn't talk about all the 15 different identities, how you focus prejudices. So that's and this next book that we're working on is going to be what makes life beautiful. Well, makes it make it beautiful. You know, and then throwing in COVID mess things up. Anyway, it's just fun. Anything else?
One last question. Have you ever worked together with them?
Yeah. Yes. Well, we always ask each other for feedback. So I sent in the scoping questionnaire. So that if you give the feedback, shares key insights of things I had thought about. And then of course she had Ryan for now I helped her analyze this questionnaire she gave the musicians. We were working on doing it now suggested. So even though she's in music and I'm in psychology, this
Then we would like to thank you for your presentation. It was really interesting.
Thank you for this. It's fun.
So, wie mache ich die Aufnahme stoppen?